All right, proof by contradiction is about following a few steps to show that something that we assume is nonsense and therefore our original postulation must be true. Okay, so our first step is to assume incorrectly that what we wanted to prove true is actually false. Okay, so whatever we wanted to make true, we say incorrectly that it's false. Then we're going to show that the assumption that this thing is false leads to mathematical nonsense. So then we have to conclude that we were wrong to assume it was false. And that means if it isn't false, then it must be true. So how does that work? Let's have a look. It says, prove using contradiction that if a squared is even, then a is even for all values of a in the integers. All right. So we start off, and this is a formal proof, so it's going to have a structure to it. So required to prove that if a squared is even, then a is even for all integer values of a. All right. Now, if we're going to contradict that, or proof by contradiction, we need to suppose that this statement is false. Okay, it's not an if-then thing. It is a supposition. All right. So here's our proof by contradiction. And we're going to say, suppose that there is an integer a such that a squared is even and a is not even. All right. So this is P and this is Q. Okay. So if we are proving it false, we're saying P and not Q. All right. So P and not Q. Alrighty, so let's see. A being not even means A is odd. So I need to create A as an odd number. And the way we do that is we multiply a number by 2 and add 1. Because whenever you multiply something by 2, you get an even number. If you add 1 to that, it has to be an odd number. So we're going to let k equals 2k plus 1, where k is an integer. Okay. Now, I know that this is an odd number, and I need to square it because I'm trying to prove that if a is odd, then there must be an a squared that is even. So I'm going to square both sides. So a squared is going to be 2k plus 1 squared. Okay. And I can expand that to be 4k squared plus 4k plus 1. And I can factorize out of 2 over here. What's interesting about that is that this part of my equation here is an integer multiplied by 2. Now remember we said that anything multiplied by 2 must be even. So let's show that in an interesting way by saying, well, 2k squared plus 2k must be an integer, because when you multiply two integers by each other, you get an integer. And we're going to let 2k squared plus 2k just be m. Okay, and that'll just simplify this. So therefore, a squared is 2 multiplied by m plus 1. Now, that number there, we know that this part is even, and plus 1 makes the whole thing odd. All right, so this is odd, so therefore a is odd. But hang on, we're saying that a squared is even. Up here, we've supposed a squared is even. So we're contradicting, because something can't be even and odd. Okay, so, but a squared can't be both odd and even, so therefore we have a contradiction. So therefore my supposition is false, and therefore for every integer if a squared is even, then a is even.